4R7. As I told you before, R means the decimal point. This should be equal to 4.7 ohm. 4.7 ohm. As you can see, we have 4.8 ohm. So this is a good resistor. Okay. This should be equal to 0.7 mega ohm. As you can see, 0.754 mega ohm. Okay. I'm going to show you how to test all types of SMT resistors using the multimeter. So the first resistor that we're gonna test is this. As you can see, we have 1 0 0. So the third number is 0. The resistance of this resistor is 10 ohm. Okay, so let's check it. We should find 10 ohm in the multimeter. So as you can see in the multimeter, we have 10.3 means 10 ohm. Okay, so this is a good resistor. Let's check this resistor also. We have 471. The multiplier is 1, so means 470 ohms. 470 ohms. So let's check. As you can see, we have 465.1 means 470 ohms. So this is a good resistor. Okay, as you can see. Here, this is a network resistor where we have 1, 0, and 3. So 3 is the multiplier. 3 means 3 zeros. This resistor equal to 10,000 ohm or 10 kilo ohms. Okay, 10 kilo ohms. As you can see, 9.93, about 10 kilo ohms. As you can see in the multimeter, we have 10 kilo ohms. So let's check this resistor also. So we have 3 zeros, means this is a fuse resistor. Okay, this is a fuse resistor. We have here in the multimeter 0.1 or 0.2 means 0 ohm. So this is a good resistor. Okay, as you can see in the multimeter, the value is correct. Let's check this. As you can see, we have 4R7. As I told you before, R means the decimal point. This should be equal to 4.7 ohm. 4.7 ohm. As you can see, we have 4.8 ohm. So this is a good resistor. Okay, this is a serviceable resistor. So let's check those resistors also. As you can see, we have 105. The multiplier is 5, means 5 zeros. We will add 5 zeros. This should be equal to 1 mega ohm. 1 mega ohm. So let's check. So as you can see, we have 0.996 or 97 means 1 mega ohm. Okay, so as you can see, the unit is the mega ohm. So this is a good resistor. 1 mega ohm. So this is a good resistor. So let's check this resistor also, the same value. We should get 1 mega ohm. As you can see in the multimeter, we get 1 mega ohm. So let's check this resistor. As you can see, we have 150 means 15 volts. Okay, 15 volts. We should get 15 volts. As you can see, we have 15.5. As you can see, this is correct. So this is a good resistor. Here we have another resistor with 754. So the third number is the multiplier. 4 means 4 zeros. This should be equal to 0.7 mega ohm. As you can see, 0.754 mega ohm. Okay, as you can see in the multimeter. Here we have another network resistor with 3 numbers. We have 3, 2, 22. So the third number is 2, means 2 zeros. This should be 2.2 kilo ohm or 2222 ohms. Let's check. We should get 2.2 kilo ohms. As you can see, we have 2.90 means 2.2 kilo ohms. So this is a good resistor. As you can see in the multimeter. Here we have another fuse resistor. As you can see, this time with 1 0. Of course, with the same working principle, we should get 0 ohm. As you can see, we have 0.3 means 0 ohm. means this is a good fuse resistor. Okay, here we have another resistor. We have 152, so 2 is the multiplier, so this should be equal to 1.5 kilo ohm. 1.5 kilo ohm. As you can see in the multimeter, we have 1.45, means 1.5 kilo ohm. This is a good resistor. Okay, here we have another network resistor. We have 681. Okay, means 680 ohms, because the multiplier is 1. We will add 10 to 68, means 680 ohms. We should get 680 ohms. So let's check. As you can see here, this is a current sense resistor. So basically we should find here 0. As you can see, we have R020. As you can see, we have 0.1 or 0.2. This is a good resistor. Here, as you can see, we have another resistor where we have, as you can see, 2R2. This should be 2.2 volts, okay? Because R means decimal point. As you can see, 2.4 ohms. 2.2 ohms. As you can see in the multimeter, 2.4 ohms. This is a good resistor. Here we have 1R0, means 1 ohm. This should be equal to 1 ohm, because R means decimal point. So this resistor should be 1 ohm. Let's check it out. As you can see, we have 1 ohm. Okay, 1.1 or 1 ohm. This is a good resistor. So this is a motherboard for the mobile phone, and over here we have 2 resistors. As you can see, we have 2 current sense resistor. We have R010. This should be equal to 0.01 or 0.1. Okay, so this is basically like a fuse resistor. We should find 0 ohm or 0.1 ohm. As you can see, we have 0.1, 0.2. This is a good current sense resistor. Samples of resistors. So as you can see here, all these samples are for resistors. Okay, for example, for this, 2 samples are for the standard resistor, as you can see. So basically this is a US sample, and this is universal sample. Okay, so these 2 samples for standard resistor. These 2 samples, as you can see, are for the light dependent resistor or the photoresistors. We have here 2 arrows here. Okay, and this sample is for the network resistor. As you can see, we have here 4 resistors. So the network resistor is a combination of many resistors. Basically, we use the network resistor in order to gain the space in the motherboard. And for these 2 samples, as you can see, are for the thermistor resistor. Okay, the thermistor resistor. Now we're gonna see how to calculate the resistor code. So generally, the SMD resistor can have 3 or 4 digits. The last digit represents the number of zeros. The letter R shows the position of the decimal point when it is placed before or between digits. Okay, so generally you can find 2 kinds or 2 types of resistors. You can find a resistor with 3 digits or 4 digits. So always the first digit and the second are fixed numbers, and the third one or the fourth one for this type of resistor is the multiplier. Okay, so here we have the first digit, the second digit, and the multiplier. Here we have the first digit, the second and the third digits are fixed, and the fourth is the multiplier. So let's see some examples here. So here, as you can see, if you find this code in the resistor. 101 means 100 ohms. So 1 means we will add 10. Okay, so 102 means 1000 ohm. As you can see, the multiplier is 2. Here we will add 2 zeros equal to 1 kilo ohms. 123 we will add 3 zeros, so equal to 12 kilo ohms. 155 we will add here, as you can see, 5 zeros, means 1.5 mega ohms. So for the resistors with 4 digits, so the first digit, the second and the third are fixed numbers, and the 4th digit is the multiplier. Here we have 1, we will add 1 0. Here we have 2 zeros. Here 4 zeros. Okay, so when you find R, so as we have here in the definition, the letter R shows the position of the decimal point. This is the decimal point, as you can see here. Okay, when it is placed before, okay, like this example, or between digits, like this example. Okay, so here we have R10 means 0.1 ohm. 5R4 means 5.4 ohm. 7R50 means 7.5 ohm. 50R0 means 50 ohm. So we're gonna see right now a note, as you can see. Sometimes instead of the letter R, you may find letter K or the letter M. All that letter shows the position of the decimal points, but with different units. So letter R refers to ohms. Okay, letter K refers to kilo ohms. Letter M refers to mega ohms. So let's see some examples. Here we have R10 means 0.1 ohm because we have R. 5R4 equal to 5.4 ohm. So here we have K10 means 0.1 kilo ohm. 5K4 means 5.4 kilo ohm because we have K. And for the M10 equal to 0.1 mega ohms. 5M4 means 5.4 mega ohm.